Okay, fine guys, let's start. Okay, so since we got bit gap, so let me try to give you a quick recap. So in our last session, what did we see guys? Yeah, so we have seen the one hot encoding. Even if 100 people are not using, so okay, so we have seen the one hot encoding. So yeah, so what does one hot encoding say is it is just trying to convert the given categorical column into certain numerical column. Fine. So for that we have seen certain techniques. So this comes under this particular concept. Okay. So where we have seen ordinal encoding, label encoding, and also one hot encoding. So encoding is what we have seen in the last class. So after that, today we are going to see new thing called as column transform arrays. Okay. So here the point is till now what we have studied is if you are having a nominal encoding, we are using specific type of encoding. For some ordinal, you're using one hot encoding. Agree? And if at all you are having certain missing values, okay, we have not seen how to handle missing values. Over here we are going to see, but in this section we will study. I mean, when mostly in tomorrow's class we will see how to handle missing values. Okay, so let's say we are having a column, we will also see how to handle missing values. So when you're doing these all three different types of processings, fine. So if you are doing all of them individually, fine, so it will be a bit difficult task to do because the length of the code will be increased every time. Okay, so here the problem is when we have mixed variables, we need to use multiple encoder, which is not simple every time. Okay, so what does that mean? We'll try to understand with an example. Okay, so am I audible guys? Just checking.
Yes, sir.
Okay, okay. So fine. So what I mean to say here is, for example, I'm taking this simple. Yeah. So I'm taking this simple toy data set. Okay, related to COVID. So first of all, we'll see the general method which we have seen till now. Okay, so we have imported the data set. Okay, this is my data, which is having age, gender, fever, city, cough, whether it is having COVID or not. Okay, simple. It's just we are treating whether this person is affected with COVID or not. After that, we have seen some basic pandas function. Okay, null values. Then what we have done? We have done a train test split. Okay, what we have done? We have done train test split. So now this is my training data. Okay, now on this training data, okay, on this training data. So you remember, so whatever the encodings or whatever the functions we apply on training data, you apply same thing on test data also. Okay, fine. So first we are taking this training data. Okay, so using this training data, what we're going to do, we are initially we are trying to use the simple imputer. Okay, what is the simple imputer? Is the simple imputer is actually it will try to fill up the missing values. Okay, which we are not seeing. Yeah, which we are not seeing imputer. Okay, we'll be seeing the missing values in this particular section, missing value section. Okay, but as of now, let's understand that it will just try to fill up the missing values. Okay, if you see the fever column, okay, so can you see these 9 columns? Right, you can see these 9 values, right? So it will try to fill up those columns. Okay, now this simple imputer is doing that function on the fever column. Okay, next what do we have? So if you observe, Age and fever are numeric columns. Okay. Age and fever are numeric columns. Okay. Gender, cough, city are categorical columns. Cool. Now, age and fever are by default numeric columns. That's fine. Okay. But here also, since fever column is having some nan values, we need to do some imputations. Imputation simply mean to fill up the missing values. Okay. So that we try to do it in the simple imputer. Okay. Now, next, what do we have? We are having gender, cough, city. All these are categorical. We need to do perform some encoding. Agree? So over here, if you see on where do we have? Yeah. So on cuff data, okay. So where is this on cuff data? We are applying one hot encoding. Okay. Why? Because you remember one hot encoding, guys. In one hot encoding, you need to specify the order. Sorry, it's not one hot encoding, it's ordinal encoding. I'm sorry. Okay. So on cuff, see, first of all, what is cuff? Cuff is what are the values in the cuff? It is mild and strong. Okay. So there is some clear order. Agree? There is some order. If it is mild, it is low. If it is strong, it is bit high. Agree? So obviously, mild is less than strong. Fine. So there is some order. Okay. So you need to apply ordinal encoding. Okay. So that's why you need to mention that order. So here I'm saying for ordinal encoding, the categories are for cuff, mild and strong. Okay. So first it is mild and then it is strong. Just like 10th inter BTech. So it's mild and strong. So then I'm fitting this. Okay. Using this ordinal encoding, I'm fitting it on my cuff data. Okay. And same thing on the test data also. Fine. Do you remember this example which we used it on the when we are studying ordinal encoding? So I've shown you. Do you remember?
Yes, Santosh.
Yes, right. Okay. So where we need to mention the levels of the order. Okay. Fine. So after that, if you see city, gender and city. Okay. So now cuff is done. Okay. So age is by default perfect. For fever, we have used simple imputer. Okay. And cuff, we have used ordinal encoding and remaining gender and city. Okay. Now in gender, you have male, female. Okay. So do we have any order here, guys, in male and female? No, you cannot say male is greater than female or male is less than female. Okay. So obviously there is no order. So you need to use one hot encoding, not ordinal encoding. Okay. And coming to city, city also what do we have? You're having like Mumbai, Bangalore, Kolkata, Delhi, right? So over here also there is no order. You cannot say one city is greater than other. So here also obviously you need to go for one hot encoding. Okay. Fine. So that's what we are doing over here. So we are saying one hot encoding gender and city. Okay. And also if you remove, we can drop first. Agree. So you can also drop the first column. Okay. Because it might lead to the issue like multiple linearity. Fine. So you're just dropping the first column and you're creating one hot encoder object. And on this, we're doing fit transform for the gender and city column. Okay. And the same thing you're also applying on the test data. Okay. So this is one hot encoding for my gender and city. Are we good, guys, till this point?
Yeah, Santosh.
Okay. So after that, what we are doing, we are extracting the age values. That means from X train. Okay. So from X train, we are dropping all these four values. Why? Because for all these four values, we already have new columns. Okay, so for all these four columns, we have new columns. For example, if you see out of this five, for except for age, for gender, if you see, we have created, we are using gender and city, we are getting it from extreme gender city. Agree? For gender and city, we are creating gender city. And for fever, you are creating it extreme fever. And for cough, we are creating it from extreme cough. Okay, so obviously new columns are created for all the four columns except age. So we are dropping these. Okay, so how we are dropping? So I'm just saying extrain dot drop all these four columns. Okay, so when you drop all these four columns, whatever you have, that will be only extrain age. Similarly on the test data set, test age. Okay, so now once you drop that, now what we are going to do, you are just going to concatenate extrain age. Okay, this means training age and extrain fever. This we are getting it from simple imputer. Okay, and extrain gender and city. This we are getting from OHE. Getting as this we are getting from simple imputer. This we are getting from one hot encoding. And extend of this we are getting from. Can someone tell me?
Ordinal.
Right, ordinal encoding. Okay, so we are just concatenating this. Agree, and also same thing for the test. Okay, that will be my new transform data. Okay, so for the given column, okay, for the given column, given data set, you need to perform these many steps. Okay, these many steps when you have mixed variables. What is mixed variables? So one is age, one is different. This is obviously at a high level, these are numerical and this is categorical. Okay, but in categorical also you are having some nominal and we are having ordinal, right? And also in numerical also you're having some missing values. So when you have different type of situations, then one simple way in the sense, I would say not the simple way. Okay, it is actually the basic way. Basic way need not be simple way. Okay, it's a basic way. Okay, so basic way is you need to handle each of the columns separately. Okay,
Santosh, I had it. We have a male and female column, right? So instead of converting, why don't we use any one numerical values for purpose? Like for example, male is for 0, female is for 1. So can we do that in such a way?
yes, but correct, I agree. But same thing will also happen here also, right? So what will happen here in the when you're saying which is gender, so I understand. So when you're doing gender, male and female, right? So you can use a simple pandas apply function, okay, and you can replace wherever male is there, you can put it as 0 and female there is there, you can put it as 1. Okay,
Yes. Yes.
and you can use that also. Okay, I agree. But but this is regarding the encoding. Okay, so
Yes.
in encoding also almost similar thing will happen. So if
Yeah,
you see
yeah,
what will
yeah.
happen,
Yeah, got it, got it. So wherever it is M is there, it will be, it's like
exactly right.
color thing, right? Yeah. Okay.
It will create gender.
Wherever it is 1, if it is first another column, wherever it is 0, 0, it's
Correct,
different. Okay.
correct. So this will create these two columns. Agree? Gender female, gender male. So wherever female, it will be 1, and here 0 and 0, 1. Similar, and it will drop one column. Similarly, it will have these some values, and finally it will drop one column. So you're having same. What we are
Okay.
saying here is what you are saying. So in place of this, you can create new column called as gender new. So and create female as 1. Sorry, let's say female 1, male 0. Okay, female 1, male 0, female like this. 1 0 1 0 1 0.
Correct, correct.
Great. So
Okay.
similar things happen. You can do this also. This for this you can use simple pandas dot apply function and create
Okay.
new column. Okay, see. So, but if you're thinking like this is a good question, but if you're thinking like how will the model know like whether you are doing this or this? Because from the model perspective, both are 1 and 0. This is also 1 and 0. This is also 1 and 0. That's the reason whatever you are doing it on the train data, you should apply the same thing on the test data.
Correct. Okay.
Okay, fine. So coming back, so now the basic way is to do each and every encoding separately. Okay, so finally you got all the new 4 columns, 5 columns. Age, we not do anything, but fever, train, gender and city and train. Okay, so that's why if you see here from 5 columns, now we created 7 columns. Okay, fine. So why 7 columns, guys? For simple imputer 1, for train and cuff 1, sorry, I mean cuff 1, for gender and city 4, okay, and for age 1. Okay, fine. So it is 4, 5, 6, 7, right? So 7 columns. So from 5 columns, a new columns created and 7 columns. Are we good till this point, guys? Any
Yeah.
doubts?
Yes.
Okay.
Clear.
Now the problem here is this is fine, no problem. Whatever we have done, that is okay. But the one issue we might face is what if the number of columns are more? Okay, now if we are having like let's say simple 20 columns, and it is not very rare, it's very common to have to minimum 20 columns in practical data set. Okay, and all these 20 columns are like again mixed variables. That means we have all types of different columns. Then are we going to write 20 steps? Okay, like how we are handling each column with some imputer. Are we going to use 20 different imputers or encodings and then again concatenate drop? No, you can do that, but that's not the smart way. Okay, now this what is smart way is you have something called as column transformer. That's what our today class is about. So from sklearn.compose import column transformer. Okay, so in this column transformer, it is very simple. So you can do what all you have done, okay, in one single place and in one single shot. Okay, so how you are going to do? So here in column transformer, so you need to import this, and inside this class you need to pass transformers. What all transformers you need to do? You need to just mention. Okay, what all transformers. So over here, if you're saying, you can give some name. Okay, for example, I'm saying tnf1. Okay, this is just variable name. Okay, transformer 1, I want to apply simple imputer. Okay, see here. So what all imputers we have used? Simple imputer, on hot ordinal encoding, on hot encoding, right? So directly you can say here itself, simple imputer I want to use on which column? Fever column. Okay, and ordinal encoding I want to use. Okay, and these are my categories: mild and strong, cuff. Okay, same thing we have done here, right? So on mild and strong, on cuff, ordinal encoding. And I want to use one hot encoding. Okay, okay, and I want to drop the first on gender and city. Same thing what you have done. Okay, one hot encoding, drop first gender and city. Okay, and remaining pass through. So what is the remaining pass through in the sense? So see,
Age.
correct, exactly, good. So we here we did not mention age column, right? We mentioned only fever, mild, sorry, fever, cough, gender, and city. Actually, you also have age column. Okay, we're not applying any transformer for that. Okay, what we need to do for the remainings? You just need to pass through. That means just pass through. Okay, just take it as it is. But if you don't want, you can also you also have some option. I think drop. Okay, so if it comes, if it sees any other columns apart from these fever, cough, gender, and city, it will drop if you mention drop. Okay, so whether drop is available or not. Okay, let me just try to see it. Okay, so as I said, for everything you need to go to the official documentation. Okay, compose column transformer. Okay, so over here if you see reminder, yeah, so yeah, reminder, what all values it can take drop, pass through. Okay, and default is drop. Fine. Default is actually drop. Okay. So, but specifically we can mention pass through. Fine. So if you see, no, if non-specified columns will be dropped if you apply drop, but if you apply pass through, all the remaining columns are not specified in the transform but are present in the data to fit the data will be automatically passed through. Okay, cool. Fine. So if you pass drop, it will drop. Fine. So that's whenever you get any doubt or question, just go to the official documentation. Fine. So if you see what all we have done, okay, from past 20 minutes in different steps in one single place, you can just do. Agree? And you can take this. Now this is my transformer object, single object. Now take this transformer and you fit and transform my extrain. Okay, that's it. Directly you are getting 87. Same whatever you got, the data set that is created. Okay, same type of data that will be created over here also. Fine. And on test data, 20 rows. Fine. And now when you print this transformer, okay, when you print this transformer, fine. So this is how it looks. Okay. So you are having simple imputer. This is my ordinal encoder. Okay, that is TF2. Okay, you are giving names also. See, TF1 is my TNF1 is simple imputer. Okay, and TNF2 is my ordinal encoder. Okay, in ordinal encoder, my categories are mild and strong. Okay, and this is my next one is my one hot encoder. Okay, where I am doing drop equal to first. These are the parameters. See how like interestingly it is showing. So mm, at one single place itself, you can understand what all encodings you have done. Okay, because everything you have done are present in this transformer. Agree? And whatever pass through, it will pass through. Fine. And finally, when you do fit and transform, now these are the values. Okay. So over here, one single, see, if you see in this single row, you have all the related values of all the imputers, encoders, ordinal, etc. etc. Getting guys?
Yeah, Santosh. So here can we see that each and every column name, like there are only those four columns?
Sorry, which one?
Can we see each and every column like earlier we have seen, right? For example, for categorical we have two columns, for city we have three columns like that. Can we see here? Or only those
No, no,
four
no, you
TNF
can
and
see, see here it is
oh,
creating
yeah, yeah,
seven
seven.
columns.
Okay, yeah, seven. Yes. Okay.
Yeah.
Got it.
So if you take this one row, so if you just see one row from here, it will show, it will create 7 rows. One, two,
Correct, correct.
three,
Okay.
4, 5, 6, 7. Yeah, I think these are the values. So if you see 1, 2, 3, 4, 5, 6, 7.
Yeah, yeah, okay.
Right? 7 columns for one single row. Okay,
Sure.
similarly, this is 7 columns for another single row. Okay, fine. Others, did you get this?
Yes, sir.
Okay, so the point here is the column transformer is okay. So how easily you can use the simple column transformer, and no matter here, even if you have 20 columns or 50 columns, you just need to mention everything at one place. Okay, and if it is ordinal, just mention the order. If it is one hot encoding, just mention all the one hot encodings at one place and simple imputers and pass through. That's it. Okay, in one single shot, you will get the transform dataset and take this transform dataset and pass to some model. Cool. So that is how important and how easy the column transformer. Okay, got it. Fine. So now we have also understood the importance of column transformer. Okay, it's just nothing, putting everything in one place, guys. In other way, it's not a new concept, but it is just making, it's just putting all the older parts into one place, okay, and making the life easy. That's it. Cool. So now next thing is, but this generally we use, guys. Okay, because one of the most important thing we need to follow when you're writing, right? Optimization of the code. That means you need to achieve the same results with minimum number of code. Okay, you can use this, even this will also give you the same result. This will also give you the same result. I hope you are getting that. Okay, because the output is same. Okay, if you pass this data to the model or this data to the model, the results are not going to be different. Same results. Okay, but the only thing is in how many lines of code you are able to get the results is different. Okay, and that will be also be a big thing, right? So instead of writing these many lines of code, if you're doing it in just 4 lines of code, that is definitely appreciable. Okay, and that should also be our focus. Okay, whenever we are writing some code, right? So you need to use minimum number of codes, minimum number of lines. Okay, fine. Now next thing is, since we understood this column transformer, next thing is I'm going to show you few things. Okay, so based upon this column transformer, if you use, what will be the benefit? Okay, we have seen one benefit, but I will show you in detail. Okay, if you don't use, how it will be. Okay, what difficulties we are going to face. Okay, so let's start, guys. Okay, for that, yeah, I'm taking this. I'll give you a rough walkthrough, okay, of this data set. Okay, just let me know or stop me if you are having any doubts. Okay, see, basically what we are doing here, I'm importing the training data set. Okay, and my training data set is here, it is Titanic data set. Okay, first thing is I'm going to show you using this training Titanic data set without using any pipeline. Okay, so the concept over here is how to use pipelines, guys. Okay, so you use column transformer, that's fine, but you also have something called as Sklearn. Okay, Sklearn pipelines. Okay, so whatever you have studied, right, so you can put that in the form of pipelines. Okay, so that it gets automatically executed instead of you doing individually. Okay, it's a similar concept to column transformer, fine, but at a bigger level. I mean the whole end-to-end process, what you want to do, that you can do it in the form of pipeline. Okay, for example, just like column transformer, oh sorry, okay, just like column transformer, so you're doing transformer 1, transformer 2, okay, and transformer 3 individually. Now what did column transformer do? It just added all thing into one place and it will become column transformer. Agree? In pipeline also, so first thing is you might do some data pre-process. I would say you are handling missing values. Again, you might do some scaling. Fine. You might do some other processing. Okay. So it will mix everything and put it in one place called as Sklearn pipeline. Okay. Fine. So here, first what we are going to do here is, since this is our introduction to Sklearn pipeline, okay, or machine learning pipeline. Okay, now we are going to see without pipeline, and we will see how can we predict without pipeline. Okay, without pipeline in the sense general normal approach which we know till now. And next thing we are going to see here is how to do the same thing with pipeline. Okay, and also how to predict with pipeline. Okay, fine. So before that, uh, may I know, do you guys have college today, or do you guys going to college? Meghana.
Yes, going.
Okay, fine. So we'll see till where we can cover. Okay, fine. So let's start. Over here, if you see, yeah, first we'll see Titanic example without using any pipeline. That means what we are just see, before that, let me explain you the imports. Okay, you know NumPy, you know pandas. Okay, this for train test, speed is for splitting. Just now we have seen simple imputer, we have seen the one hot encoding, and min-max scaler we have seen in our scaling class. Okay, and this is just a new thing called as decision tree classifier. Okay, this is a model which we have not seen. Okay, but I think you might have heard this model. Okay, I spoke many times like decision tree classifier. Okay, so this is just one more. This is just model. Okay, you don't need to understand this. Okay, but just understand that this is a model. Okay, I think apart from that, you know every other import. Now over here we are just importing the data set, training data set. Okay, this is my Titan data set which you are aware. Okay, we have discussed it many times. On this, I'm dropping few columns like passenger ID, name, okay, tickets and cabin. Okay, and I'm taking only survived class, passenger class, 6, age, okay, and a few other columns. Agree? And then this is my train test split. Okay, this is my train test split. Okay, and this is my train data. Okay, this is my y train. This is how I'm checking the null values. Okay, fine. So mainly the imputations. Agree. So the simple imputer, I'm applying the simple imputer. Okay, I'm saying what? I'm saying strategy is most frequent. Okay, so see, as I said, the imputations is to handle the missing values, guys. Okay, which we not cover it. We are going to cover. Okay, but just we came across this. What does this mean is here I'm going to fill up with the most frequent value. Okay, so this there are two types of imputers actually. Okay, one is simple imputer, that is for age. Okay, see here guys, don't get confused. So over here if you see, this simple imputer is for SI age. SI age is SI age, this is a variable name, that is simple imputer. Okay, here I'm not using any strategy. But for embarked, okay, this is one more simple imputer which I'm creating, okay, with a strategy called as most frequent. That means it will fill the values with the most frequent values. Okay, it will fill the values with the most frequent values. Okay, that is one more imputer I'm creating. Two imputers I've created. Okay, but here if you get, if you're thinking like, if you don't give any values, what will be the strategy? Okay, what will be the strategy? Fine. So let me see. Simple imputer. By default, it's mean. Okay, by default, it is going to fill up the values with the mean value. Okay, but you can also use median, you can also use most frequent, you can also fill it with some constant value. Okay, fine. So over here, one is simple imputer. Okay, that means here it will replace with, fill with the mean values. That means what, guys? That means what? If you're getting confused, that means if you, let's say you're having null values, right? You're having null values. If I'm using simple imputer over here, okay, if I'm using simple imputer over here, that means it will take the mean values of all the other values and it will fill those mean values over here also. By default, simple imputer, the filling strategy is mean. That means take the mean of all values and fill wherever you're having null values. Okay, but you can also use something called as most frequent. Okay, in other words, it's also called as median. Sorry, mode. Mode is what? Mode is the most frequent value. Okay, so that means if you use most frequent, okay, usually we use it for categorical values. That means which category is appearing most number of times, it will use that and fill wherever there are missing values. Getting?
Yeah, Santosh.
Okay, so now here, that's what I'm doing. Okay, for this is one more imputer. Okay, I'm saying a most frequent. And this SI age, on what column I'm using? I'm using it on age column. Okay, so this simple imputer, this SI age imputer, I'm using it on age column. Okay, why age column? Age column is having some missing values. Okay, and I just want to use the mean. I did not mention anything. Okay, that means it by default it will use the mean. Cool. Now coming to embarked. Okay, I'm using it on the embarked column. Okay, so where is this embarked column? This embarked column. Okay, this embarked column, if you see, this is a categorical column, guys. Agree? So obviously I cannot take any mean or median. Fine, so that's why I have used most frequent. Okay, so in this, wherever like whatever the category, whether it is S or C, I don't know, but whichever category is appearing most number of times, use that and fill wherever we are having the null values. Okay, that's what this simple imputer strategy most frequent means. Okay, that is S embarked. So SA embarked, I'm fitting it on embarked. Clear? Any doubts, guys, in these two steps? Let me know if you're getting confused or any doubts. Great. So you are using it on the train data. Okay, same thing you're applying it on the test data. Okay, fine. So this is regarding the imputation. Okay, that means regarding the missing values. Now, next is one hot encoding. Okay, so one hot encoding. Okay, I'm using it on one hot encoding. I'm using it on for the 6 column, and also I'm using it on the embarked column. Okay, so next we are fitting it on. This is my 6 column. Okay, and also I'm fitting it on my embarked column. Fine. So why? Because if you see, these two are categorical in nature. Okay, 6 male and female, and embarked also S and C. Here also I don't know S and C, there is no order. Okay, that's why I need to use one hot encoding. Here also male and female, I cannot differentiate. That's why I'm saying one hot encoding I'm using. Okay, so two one hot encodings I've used. Okay, fine. So this is my new train embarked. And after that, this is my, okay, uh, train embark. Okay, this is my train data. So now if you remember on the one hot encoding, okay, when we are studying one hot encoding, I told you there are like two things. One is dummies, okay, pd dot dummies, okay. Second thing is one hot encoding. Both will do the same thing, but the difference here is pd dot dummies will directly apply to the dataset. But for one hot encodings, you need to create one hot encoding separately and then come and concatenate to the our train datasets. Okay, come and concatenate to our datasets. It will not directly apply to the training dataset. Okay, this is the point I have clearly mentioned. Hope you remember this. Okay, so now they're doing the same thing. So here we have done the one hot encoding everything. Okay, but this is not yet on the this will not reflect on the actual training dataset. Why? Because if you see, that's why I'm showing here my xtrain. It is still the same. See, no one hot encoding. Exactly whatever you have over here, the same thing. Okay, but what is happening, we are just creating certain columns on hot encodings and we need to apply that. How you can apply? So you need to drop the columns. Okay, because on 6 age and embark we have applied some imputings or encodings. So now you don't want this original column, so you are dropping it from training data and also test data. Okay, and then you need to concatenate the newly created columns. Newly created columns are my xtrain 6, xtrain embarked, and xtrain. What is this xtrain remaining, guys? What is rem? Oh, I think this is remaining. So when you are dropping these columns, so whatever that is remaining, okay, that is the P class, SABSP, PR, okay, those columns are extend remaining. Okay, on this, I'm adding the extend age, 6, and embarked columns. Okay, because I have done some imputings and encodings on these 3 columns. Okay, same thing I'm doing it from test. Okay, let me stop here, guys. Are you guys on track or lost track?
Understand, Santosh.
Okay, fine. So we're not doing anything new. Okay, same thing. So imputing I'm done. Okay, at a high level, if you see, I'm just done imputing, simple imputing. So there are different types of imputing, so that's what I told you in detail. Okay, but at high level, if you just see, one step is imputing, that's it. Come down, what we have, I'm done the one hot encoding. Okay, on 2 different columns, that's it. Come down, just drop the original column just like how we have done, and then concatenate the new columns. That's it. Okay, now this is my new train data, new test data. After that, I'm just fitting these two model. Okay, so if you remember, we have already seen one end-to-end ml data set approach, right? So ml flow we have seen end-to-end on some toy data set. Okay, and on that, similarly we are seeing the here we are applying the decision tree classifier. Okay, this is a model, don't worry about this as of now. Okay, but I am fitting it on my xtrain transform. Okay, on my xtrain I'm transforming. Okay, and after that you can do predictions using the test. Okay, I'm training it on my train data, and on test data I'm doing the predictions. Okay, fine. So, and this is my accuracy score. Fine. And after that you need to pickle. I'm picking 3 things, guys. What all I'm pickling? One is a model, obviously you need to pickle. Pickle is what? Saving, right? I have shown you pickling. You guys remember pickling? Anyone
Yes, Santosh.
remember? Okay, great.
Yes, yes.
So same thing we are doing here. So what all things we need to save or pickle? Obviously the model. So CLF is my classification model that you need to pickle. I'm doing it over here. Okay, so I'm creating a models folder. Inside that I am doing this model.pickle. Okay, this is my pickling. That's fine. But apart from that, there are also 2 other important things. Okay, that those are one hot encodings. Because why? What type of encoding I have applied on the training data set? Okay, so for the test data set, also I need to apply the same thing. but you might get the doubt that I'm already applying it on the test data set. Okay, that means what? See, for example, this yeah. So my one hot encoding, whatever I'm applying on the training data set, okay, I'm applying it on the test data set also. Okay, but this test data set is from our data set. That means what we have used this from the overall data, we have divided into test data and training data. Agree? And now we are applying on the training data and also test data. That's fine. Model is created, CLF model is created. That's fine. But once if the model is working well, fine. So we are going to use this model for the actual data, right? Not on our data, or not on our test data, or not on our training data. This training data is for training and test data is for testing and coming up with some evolution or accuracy metrics. Till here it's fine. Okay, but what if you have handed this to a company, okay, and they started using this? They will use the data, right? So that is actual data, live data, dynamic data. Fine. So on that data also, that data is also similar to test data. Agree? That is also similar to test data. The only difference is here we are creating the test data. There we are not creating the test data. It is directly coming from the user. Okay. No matter whether it is from us or from others, that is a data that is coming as an input to the model. It should again pass through what all we have done. All right. So that's why these encodings also you need to pickle. Okay. So that's why what we are doing here, guys. We are also pickling this imputer and also this encoder and this encoder. Okay, as an example. Okay, so over here, if you see OHC6, what is this OHC6? This one hot encoder that we have applied it on the what 6 column. Okay, and what is this OHC embarked one hot encoding? We have applied it on the embarked column. Fine. So we are using that and pickling those. Agree? So you are pickling 3 things. So if I show you,
But also, Santosh, we have
correct, good
simple
question. I was
for
waiting
one
if
side
someone is
or
going to ask. Right.
missing
So
value.
right. So you also have this simple imputer and also simple imputer most frequent. Yeah. So I think you can also pickle those also. Okay. But the thing here is the most frequent value, whatever you are doing here, right? So what we are doing here, you are fitting the values. Okay. So the one thing you need to understand over here is whenever you are passing a single row, right? Whenever you are passing a single input row, okay, so there obviously that should not have any missing values. Okay, so here you're applying it on a set of data set. Okay, so that means what? On the training data you have applied this single I would say missing value imputer. Okay, and also on the test data set also we have used this single value imputer. Now the overall data set, okay, is imputed. That means there are no missing values. Now you can also pickle this. Okay, but the reason why I not pickle here is because I might use this or I may not use this mostly. Why? Because if when I'm passing a single row, okay, when I'm passing a single row, so you can make sure whether there is no missing values for this what the column age column and embarked column. I can make sure manually and see whether there are values present for this age and embarked. Then only I can send that row manually. But here I cannot do encoding, but for every column I need to do encoding. That's why these are mandatory. Are you getting? For 6 column
Okay,
and
okay,
for
got it. But
for 6 and embarked column, fine. So I need to definitely do encoding, whatever be the case. Okay, if at all, if a new row is coming, okay. For example, have handed over this to a client and he is sending a new row. For every column he has sent in the 6 column, whether it is male or female, okay, and for embark whether this is S or C, whatever the encoding value is sending, I should definitely do some one hot encoding. There is no way. Okay, I should definitely do the one hot encoding. Fine. And what type of one hotting I need to do? It should be similar to what I've applied it on training data and test data. So that's why I'm pickling this this encoder and also this encoder, I am saving it so that I can apply it on the new input that I am sending for the predictions. Okay. Similarly, I got your point. I can also do it on the simple imputer. Okay. But yes, what is the purpose of the simple imputer? Okay. Just to fill up the missing values. Okay. So this I might use, I might not use. Agree. Mostly if I'm passing a single row, okay, if I'm passing a single row, I can make sure if the value, if it is not having any missing values or not. Okay. But as you said, you can also try with this simple imputer also. Okay, no issues. You can use a simple imputer also and you can pickle that also. Okay, that's completely fine. Okay.
Yeah, because why I have asked means in real time we'll get huge data each and every day, right? So there may be a chance to have missing values in those columns. Uh,
Yes, yes,
because of that, yeah.
yes. I
And
completely agree.
I did not understand what does it mean if you pass a single row, single record. I did not
Oh,
because
okay. See, what I mean to say here is you're having a from the data you're having trained data and you're having test data, right? So while you are doing predictions, I'm passing the whole test data. See, while training, I pass the whole training data, model is trained, and while testing, I pass the whole test data through the model, and I got the predictions. From that only, I got the accuracy. If you see here, I pass the whole X-test transform. Okay, and these are the corresponding values of my X-test that are vibrate. And this vibrate, I am comparing it with y-test. I got the accuracy. You are getting this?
yes,
Okay, that means what? In X-test, let's say there are some 50 rows. Okay, there are 50 rows. For example, how many rows are there? 179 rows are there. Okay, 179 rows are there. I'm passing overall complete 179 rows at a time to this CLF, which is my model. See here, model, and I'm saying predict. And this each value is the output of each record from this X-test. Okay, for each and every row, 179 rows. For every row, it will go to the model and it will do whatever this decision tree classifier logic is there. It will apply and it will come up with some prediction, and that is this first row output prediction, second row prediction, like that. 179 rows, these are 179 rows prediction outputs. Agree?
correct.
So what this is done, what I mean to say when I say when I said I'm passing single row, like when you are using the model, okay, when I handed it over, so usually it will be like one to one. Okay, that means for single user, you will pass the record and the model will give you output. You can pass the bunch also. Okay, you can pass the bunch also, but usually what we'll do is you will pass a single record. Okay, that means single user record, and you will get the output. Okay, usually
Got it.
when we are using, okay, each user will use it at a time, right? So that's what
Got
I
it.
mean.
Got it.
Okay,
So
so
we will, I mean, if
mm,
it is a distributed application, I mean, we'll give to the client. If it's a web application, then only one at a time, one person at a time, one user at a time will use this. In such a way, you're telling?
I could, yeah, I mean to say, yeah, distributed and web application is fine. You can understand it that way. Okay, but let's say when you are deployed it in some server, right? So what I mean to say is, if 10 people are using, okay, so but there will be at least some minute time gap between each and every user.
Yeah,
Fine,
yeah, got it.
right?
Yeah, using
So
application, yeah,
right.
using model.
Yeah,
Yeah,
so whenever it is hitting the model, so it will give you one output at a time, right?
correct, correct.
It cannot give two outputs at a time. So you cannot see the difference, okay? Or there can be multiple servers, okay? But usually it will be one row and one input and corresponding row predictions, okay? So that's what I mean to say. Fine. So you can also, coming back, you can also import the simple imputer part also, okay? But let's say now you got three imputers. So one is one hot encodings, okay? One is classifier, okay? So this is my just training part, okay? Are we good till this point, guys?
Yes, sir.
Okay, fine. So now we got these three. Now, if you want to predict, okay, so without using any pipeline, we have done, okay, all this. And if I want to do predictions on this model, Okay, on the CLF model, if you want to do some predictions, okay, this is just to test. This is not predictions, guys. So whatever we have done over here, okay, this is just for the accuracy. Okay, training is done on trained data, testing data we have passed, we got the predictions, we got accuracy. This is just on the model accuracy purpose. I have used this test data. Okay, and after that I've imported my picklings. Okay, but now if you want to do the actual predictions, okay, now I will take you to this predict pipeline. Okay, predict without pipeline. Okay, because I have developed without any pipeline. Okay, I have also predicted without any pipeline. Okay, so over here I need to pickle. Okay, see here I'm dumping. Okay, I'm dumping all the models or one hot encodings, all these three. Okay, pickle dot dump. Now, if you want to load them back, pickle dot load. Okay, pickle dot load, pickle dot load. Okay, I've loaded the model. I have loaded the, what is this? I've loaded the OHC embarked and also OHC sex column. Okay, now see Karthik, what I mean passing a single column is this. Okay, so I'm just passing one test input, single row. Okay, so here I need to pass what all the inputs that is required. Okay, so 1, 2, 3, 4, 5, 6, 7 inputs. So 1, 2, 3, 4, 5, 6, 7 inputs. Okay. So these are the inputs I need to pass. Okay. So that I have passed. Now, the important thing here is, see guys, the important thing here is, what are the inputs are there here, guys? So if you see here, the inputs, this is my actual, my trained data set. If you go to the top, what does my trained data set look like? It is looking like this. Okay. After dropping few columns, this is my trained data. That means passenger class is 1 and sex is male or female, 45, embarked is yes. Agree? This is my actual training data set. After doing all the transformations, etc., it will look something different. Okay, it will look something in zeros and ones. Okay, it will look in zeros and ones. But the original data set is this one. Original data set is this one. Fine. So now when we are saying to someone, let's say you guys have developed this model. Okay, you have done all the encoders, you three of people. Okay, and now you are giving to me. Okay, and we are saying just pass any input record. Okay, and pass it to the model. Model is going to give you the prediction. Okay, whether the person is alive or not. Okay, something survived or not. Getting is my point clear till this point?
Yes, Santosh.
Okay,
It's like you are a user.
I'm a user.
You are going
Okay,
to enter the data.
fine. You guys are the developers. I'm the user. Now, when you are giving me, so obviously I will understand this data set. I will pass. I am happy to pass in this way. Then this, because I cannot understand what is the zeros and ones. What are all the zeros and ones? I cannot understand, right? So internally you are doing whatever you want to do. You can do. You want to do encodings, imputings, whatever you want to do. You can do. Finally, which will go into the model for predictions. Okay, but for the user, he doesn't care about all this, right? He will just say, hey, I have this input, this is my passenger class, and he's a female or male, and it is his age, and these are these values, and this is my fare embarked is yes or no. Okay, he will pass in this manner. Agree? So that's why if you see, if I'm predicting without in this notebook, if you see, okay, let's say you are getting this input. See, this is still in the original without encoding format. Okay, so this is my class, this is my mail. Okay, I got this. I'm passing this input. Okay, I'm passing this input. Agree? But the model does not know this input. Agree? The model does not know this input. Why? Model, whatever, see, from model perspective, if you see, this is my model. Model does not care about all this. If you see, this is my model, and to the model, I'm fitting what? X transformed I'm fitting. Model will care or will understand only this X transform. It will not understand anything at all. Now, what is this X transform? This is my X transform. And what is this X transform? It is concatenating of all this. And what are all these? These are all the things we have encoded and pass it to the model. That means what? This value. Okay, zeros and ones or inputings, etc., etc. Agree? So the model will understand only this encodings. Okay, but the original data set is this. Whatever the model will understand is this. Similarly, I am passing this as a test, but model cannot understand this because model can understand only this encoding. So that means I need to convert again this also into encodings. Getting?
Can you please repeat once, Santosh?
Yeah, simple. So I'm saying, see, the original data set is this. Okay. See, original training data set is actual data set. Okay.
Correct, correct.
I am doing some encoding, okay, and sending to the model.
Yes.
Okay. Now model will understand only this encoding. That means what? These
Correct.
encodings.
Correct.
Okay. It cannot understand this actual. It cannot understand this actual data because these are all categorical data. Male is, it cannot understand this. It can understand this encoding data. Fine. So that's how it got trained. Okay. And as you can see, it is trained on this transform data. Okay. Till here it's done. Now, when you the point here is when you are passing a new input, okay, for predictions, okay, you need to again pass it in the encoded format only for the model. For any predictions you are going to do, okay, just like how we are done, right? So see here, when we are passing the CF, when we are using this here predictions, okay, what we have passed, we did not pass X test, we have passed X test transformed. Agree? Just how we have did the transformation on the train data, we have applied the same transformation on the test data also, and we have passed it for the model predictions. Even though we have direct, but actually we have only X train, X test. We did not pass X test directly. We have applied all the transformations wherever we are applying on the train data, we are applying on the test data also. See, here on train data, we are applying on the test data also. Fine. So finally, we concatenated for the train data. We also concatenated on the test data also. Fine. And for predictions, we have passed test data. Agree? Similarly, how we are doing it here, even for a single record also, you cannot pass directly. You need to encode it and pass the encoded values. Getting?
Yeah, Santosh.
Everybody? Okay, great. So just like how we are doing this encodings, right? Simple guys, just how I have transformed this train data, test data, and use it for training and prediction. The point here is simple. So now, if a user is passing the input, obviously he's going to pass it in this way. Now the point here is we need to again apply the same sort of encodings. That's why we have pickled those and convert this single row into encoded row. Okay, so that it will convert it into something similar to X test transform, so that you can pass it for the prediction. Got it?
Yeah, Santosh.
Okay, so now this is my single record. Okay, and on top of this is my test input. Okay, and on top of this I am doing OHC.6 transform. Okay, that means what? Models. See, I have pickled there and I'm loaded here. Now this OHC.6. Okay, that I'm transforming on my test input. Okay, and then this is my input. Okay, and on what column I am using it? I'm using it on only second column. Okay, and that's how I'm mentioning this. Okay, this is column, this is row, this is column. Agree? I'm applying it on my index 1. That means this is 0, this is 1. Okay, only on the index 1, this is my sixth column. I'm applying this OHE.6 one hot encoded transformation. Clear?
Yes, Santosh.
Okay, and after that, now if you see this, so this is my output. Okay, it created 0 and 1. And after that, I'm applying this OHC embarked. Okay, transform on which column I should apply? This column, last column. So that's why I'm applying it on last column, -1. Okay, and I'm getting 0, 0, 1. This is my output of this column. Now, actually, now if you see what are the values of embarked values could be S, C, and there might be some other value. Okay, so let's see. Yeah, so over here, if you see df embark dot, yeah, total there are SCQ. There are 3 values without the numbers. There are 3 values. Agree? So now here it is S. For this S, the embarking is 0, 0, 1. Okay. For this S, the value is 001. Agree? This is one hot encoding. Fine.
Yeah.
So the reason why we are using the same one hot encoding is because we have used the same on the train data. If you don't use this, if you again do, if you don't pickle and load it and use it on the same way, it might create instead of 001, it might come with 100 or 010. This is also one hot encoding. This is also one hot encoding, but this is different from from what we have used it on that actual train data. Okay, and the model might not work well. Just to be on the same page, we are using the same one hot encoding which we used on the model training. We are loading that and using it on the same. So what value it has used for the S? Okay, same thing it will use it here also. Same type of encoding it will do on hot encoding. That means, or what value it has dropped, it will drop the same column. Okay, and after that, what we are going to do, you are using the test input. Okay, and you are concatenating all the values. Okay, what are the values you want, you are using those, and you are dropping this. Fine, you are dropping this mail, you can drop this mail, and you can drop this yes. Okay, and you are concatenating, you are creating the column. Fine, and this column, whatever you are having this test input transform, you are passing it as a prediction. CL dot predict transform, and this is my output 1. Same thing, like how I have shown you. Here we are doing at a bunch. 179 values I'm passing CF dot predict X test transform. This X test transform is 179 values, right? You are passing all of those for and asking the model prediction. In similar way, I'm showing it for a single record. Agree? So test input, you are passing the single record. Where is my record? Just like see, this mail and S will be dropped, and in the place of 6 we'll have 0 and 1. In the place of S we'll have 0 1 0 1. Fine. And that this, if you print this, you will get okay 10 row columns are there. Okay, that value you are passing as an input, and if you say predict, it is giving you 1. This is how you can do the predictions. Getting guys?
Yeah, Santosh.
Okay, fine. Okay, so I would say that's all for this class. Okay, so in the next class, or in the, if possible today evening, we'll connect and we'll see how easily we can do with using pipeline. Okay, so these two are, this is building the model without using pipeline, and predicting doing the predictions without using the pipeline. Okay, so same thing we can do with using some Sklearn pipelines, and you will see how easy our life would be. Okay, and we can compare, and then we'll have the comparison. Okay, and don't worry, I will show you one more example. Okay, if you're getting confused on this row, so I will just do a quick recap in our next session. Okay, so, and I will also try to share this notebook also, and you can go through. But we did the same thing. Okay, just like how what all transformations we are applying here, right? We are applying the same thing over here. Okay, so, and dropping the columns, fine, and dropping the columns, and we are just concatenating, and you are sending it for the predictions. Okay, fine. So, once we complete the second part also, then you will have the whole picture, and then you can let me know if any doubts.
Sure,
Okay.
Santosh.
Okay, fine. Yes, thanks. Let's meet again.